Okay, so welcome back. In the previous page, we have mentioned how to construct KT tree for as a index table for the multi-dimensional index queries, right? Before we take the relation with two attributes or a space with two dimensions as example. So for the relation with more attributes or for the space with high dimensions, and the KT tree construction as well as the query process will be very similar. However, we have more dimensions to play with, right? Here we show you with the example, if we have a relation with three attributes, or we have a space with three dimensions, then we also construct a KT tree with three dimensions instead. In other words, we can have a three-dimensional KT tree alternate splits according to the x, y, and z coordinates respectively. And when we do the query, it will also be very similar, and we want to query for some data points inside a box instead, right? Because we have x, y, and z, these coordinates respectively, and all the points lying inside this box will be returned as a result, right? So this is about the query. According to higher dimensions, we can construct a very similar KT tree data structure, and which can serve as an index table and can help us to speed up the query process time cost. So here, as we have a high dimensions, actually, the region or the physical meaning of lines will be slightly different, right? Before, for two dimension, we can say we can draw some lines. However, when it comes to three dimensions, what we can draw is actually we can draw a hyperplane, right? According to the value of x, we can draw one hyperplane, or one plane, which can split the region, the 3D dimension region, into two parts, the left-hand side, right-hand side, right? So they will be split by one hyperplane instead, right? It's not a one line anymore. It will be similar if we want to split according to the y and the z axis, then we also need to draw some parallel planes according to the y and z coordinates respectively. So also for the intersection between the region versus the value range, it also depends on the intersection of the faces, right? Because before, if we do the intersection between value range as well as the two-dimensional space, we just want to find the intersection between these two areas, right? However, when it comes to the intersection between a high-dimensional space versus the provided values, we want to find the intersection of the faces, right? And also analyze by the x-parallel planes instead, which will be more complex as we have more and more dimensions for the KT tree. So this is about KT tree for the query processing. And if you I'm not sure if you have done machine learning before or not. If you have done machine learning, right, you should also know, right, that we have so many data structures or model structures which are in the tree diagrams. One important model is called decision tree, right? For decision tree, it can also classify the data points into different classes or different clusters according to the provided value of the attributes, right? And we can also partition the data sets according to the value of the attributes into different subsets. However, for the decision tree, it is a machine learning model, and we can learn the features to be used for splitting the data sets. It is very different from the KT tree here, right? For the KT tree, we just split according to the density, right? We have half nodes on one side and half on the other side. However, for decision tree, we need to split the data sets according to the specific feature values we can learn, right? And we can also adjust the value accordingly as we have different data sets. So for the decision tree, we can further partition data sets into different classes. So for all the data points in the leaf nodes, they will belong to the same class, right? And the physical meaning of the leaf nodes will also be very different. They are very different tree algorithms, and so for decision tree, it is for machine learning. However, for the KT tree here, it's for the database system as index tables. So you can also compare them with each other to have a deeper understanding and also connect them together, right? And then you can understand why the tree is very important in computer science. Because when you use tree structure diagrams in both database, in machine learning, data mining, and in many other areas, it is very useful and also can provide a very rich semantical meanings of the partition, querying, as well as learning process in different areas as we studied. Alright, so this KT tree we have introduced, and next we will introduce another tree structure diagram which is called causal tree.